Thanks, Natalia, and thanks for letting us host this event today. And thanks everybody for being here. Hopefully you enjoyed the empanadas. I mean, for a simple logistical announcement, so restrooms are that way. And yeah, so I will tell you something about AdRoll and of course about TrailDB, which is an internal tool that we open sourced a few months ago. Let me put the timer on so I don't run too much over time. So the title of the talk is Processing Trillions of Events with TrailDB. And so don't be surprised if you haven't heard of TrailDB before. So as I mentioned, it's a new thing. And I mean, this is the first time actually that we are giving a public presentation about this. And so what TrailDB is. So TrailDB is an efficient tool for storing and querying series of events. And so what that means is that, well, first, it's an efficient tool, which means that it's actually not the framework. It's not like Spark. It's not like Hadoop, or it's not like any kind of a big a platform that would require you to stop doing whatever you have been doing before. But it's a simple tool that does one thing and hopefully does it well. Also, it is a tool for storing and querying data. So that's the database part. That's what databases do. And then most importantly, it's a very domain-specific database for storing and querying series of events, meaning data especially that happens over time. And now, since this is data mining meetup, and I presume that like many of you are actually data scientists, or actually let me ask you, so how many are data scientists or identify themselves as data scientists? Okay, cool. So I mean, in that case, I mean, like you guys surely have used many different tools for handling large or small amounts of data. So I was actually at the Data Science Summit last week, which was organized by this company called Turi or Datto. And they were talking about their thing called S-Frame, which is kind of like DataFrame, which is kind of like data table, which is kind of like Pandas, which is kind of like NumPy. So there are like so many of these things that like, what's really the reason? And of course, one thing is that like you have these language boundaries. So I mean like, so how many of you actually use R? Okay, good number of people. So I mean, then of course you are familiar with the original data frame and maybe data table and so forth. And how many use Python? Maybe some overlap there. Yeah, so in the Python ecosystem you have Pandas and you have NumPy and you have SciPy and so forth. So there are definitely many of these tools. And I think that there's actually a good reason why many of these tools exist. So I don't think that it's only about like reinventing the same wheel. But I'm actually personally, I'm very interested in always learning that like why do companies end up doing something differently? And so that's why I wanted to start this presentation by giving some motivation and background why we implemented TrailDB in the first place. To kind of give you the background, I mean, I have to start from the beginning, I mean, to tell something about AdRoll. So AdRoll is an advertising technology company or a marketing technology company or a marketing platform. And now if you think about marketing, so what it basically means is that our customers come to us, they come to AdRoll with the idea that they want to get more paying customers. So basically, AdRoll is a platform that produces you more paying customers or more money, which is kind of a nice service to have if you are a company. And now the interesting thing is that like the advertising technology or marketing technology ecosystem today is of course like way different, or the field is way different than what it used to be in the past. Of course, like before the technology part even existed. So if you think how things work in the days of Mad Men or something, so I mean, you want to get more customers, you go to an advertising agency, you have coffee and you have pastries, and you talk with designers and you talk with copywriters, and they come up with an advertising campaign for you. And like that's how it used to work. Well, now with AdRoll, the interesting thing is that maybe most of our customers, or at least a large part of our customers, come to AdRoll and they launch a campaign with the idea of getting more paying customers without ever talking to a human being, or just by using the web interface and so forth. And this is kind of magical. So somehow we are supposed to be a company that produces more paying customers kind of out of void, out of nothingness. I mean, like no human being ever even understands what you are trying to sell. I mean, that sounds like a snake oil. I mean, we don't even know what you are selling, and we are supposed to find you more customers. And of course, the answer to that, given that this is like a data mining meetup, is that like we look at the data. And so now one interesting piece about data is that like, well, first, I mean, we don't just look at the snapshot of data, but we actually collect data over time. We collect data in real time. So how it works is that if you want to become a user or customer of AdRoll, you place a piece of JavaScript at your website that collects data about every single person that visits your website. And like it basically sends the data in real time to AdRoll. So we get this big fire hose of data coming in over time. So that's actually what you see here is an actual visualization of data over 24 hours. So x-axis is time again, 24 hours. If you, let's see if this works. If you look closely, you can actually see that there's a brighter area here in the middle that corresponds to the nighttime in the United States. This is data from United States, so not so much activity happening at nighttime. And now the interesting fact is that we collect data about users, so specifically about users over time. So the y-axis here are different users. So this visualization is actually a sample of 250,000 people in the United States and what they have been doing at AdRoll customer site over 24 hours. So this is the kind of the data we are interested in. And there are like different types of events here. So it's very hard to see probably, but there are actually red dots all over the place here. It's like as if the visualization had chickenpox, and those are ads that we show to people. And then there's actually, you can see that there's this like a stripe in the middle that corresponds to some third-party data that we get every night from our partners. And then all these little gray dots here are page views when people browse the web pages that have the AdRoll pixel on them. So there is a lot of data coming in. So it's actually overall, we are collecting tens of billions of data points every day. And again, I mean, the point is that somehow we are supposed to convert this massive fire hose of data to paying customers. And now if you look at this visualization, of course, it doesn't look like much. It's just like a big, like a cloud of noise, nothing much interesting. However, what you can do is that you can take the same visualization and you can sort the rows. So if you look at these users here, what you can do is that you can sort the rows of this visualization by the account, by the customer of AdRoll. And what you see in this case is that like suddenly all these different patterns emerge. So you can see that like there are these dark areas, and now suddenly you actually start seeing those red dots there. You can also see some yellow dots here and like all kinds of things happening. So actually there is lots of information in this data. So now the really interesting part is that like in this like very simple visualization, I mean, you can already see many of these patterns. You can see these like campaigns that start at night or in the evening. You can actually, this is like a special type of campaign, prospecting campaign that launched. You can see that some accounts are active mainly during business hours. Maybe they are selling like something business oriented. People don't go to those sites during nighttime or evenings. There are some sites where people spend a lot of time. I mean, maybe it's very engaging. I mean, they just browse many pages on those sites. And then actually it's maybe very hard to see here, but then there are actually some like strange effects that there are some users who seem to never sleep. They just produce a uniform amount of data over hours and hours. And of course, that doesn't seem very human, and oftentimes it isn't. It might be bots that are actually fraudulent, and we want to get rid of them. So now the key thing here is going back to what AdRoll does, is that I would claim that everything AdRoll needs to run this pretty sizable business, what we are doing today, is actually contained in this visualization and in this data. So we can, by extracting the right signals from this data and by extracting the right features for machine learning models, we can make our customers' campaigns perform more efficiently. And when the campaigns perform, I mean, the customers make money and they are happy and they stay with AdRoll. If we screw up and like we don't extract it or we can't extract the right signals from the data, then the campaigns don't perform and the customers leave. So basically, it is very much the business of AdRoll to look at data like this and try to understand what's going on and to basically apply machine learning and different methods to then like make the campaigns more performant. So that's pretty much the reason like why we are interested in this type of data, and also that like why we built TrailDB. So if you look at this visualization and like you imagine that we zoom in and we zoom into, let's say, like 4 rows of this big visualization, it obviously looks something like this. So again, I mean, you have these different types of events here. They are still ordered by time. So time is growing in ascending order. And like we have different users here, and these different squares correspond to different events, different type of actions that users perform in this data set. So like in this case, these could be different ads that they see or different pages that they visit and so forth. So now the thing is that like you can take a subset of these users and you can take a subset of a slice of time and you can package it up, and that's basically what TrailDB is. So it is basically, like I said in the beginning, it's a way to store and query this data in a very efficient manner. So now, of course, the thing is that like if we go back here, this is, I mean, of course, a very small subset of all data we have. It is actually a very interesting question that like how do you store the data in the first place so you can query it efficiently. So back to the point what I mentioned about AdRoll's business being very much about extracting the right signals from the data. Now there's one big challenge with that. In general, we have no idea what we are doing. I mean, we have no clue. So it would be way easier if we knew exactly, I mean, what type of things we are looking for, but that's not the case. So it's a very exploratory process. I mean, like we need to iterate and like try out different ideas quickly. And like also another like limiting factor is that like AdRoll is still a smaller company. We don't have infinite resources, so we want to have tools that like we can use very efficiently. And that's also really a motivation for thinking that okay, so like what kind of tools could we use to analyze data like this in a very efficient manner and in a very productive manner. So that kind of brings me up to the kind of the actual topic that okay, so what is exactly TrailDB? So like I showed you, I mean, it's a very simple data model. We always assume that like these users that we are interested in, they have some kind of an identifier, so user ID, or actually they don't have to be users. They could be even like Internet of Things devices or whatever. But I mean, the point is that there's some primary key. Then like the interesting thing is that there are events, some actions, something that happens by these users, and these events are discrete. So that's an important thing, that in contrast to metrics or continuous things that you can record, in this case we are interested in discrete events. And you can think of something like JSON objects that have different fields and so forth, rather than like just having like one number over time. So it's not like a line chart over time, but it's rather like some discrete, like structured events over time. And now, over time aspect is of course this history. So we keep collecting data over time. So we have really a large amount of data over time. So the data model is really focusing on this idea that like we have the primary key, we have some events, and we have some history, and that's what we focus on. And that's actually really important. That like TrailDB is not a general purpose database. It doesn't replace Postgres. It doesn't replace your key value database. It just answers this question that if your data happens to be in this format, I mean, how can you handle it efficiently? Now you might be thinking that, okay, so well, I mean, of course you can store events over time in many different databases. So what's so special? I mean, like how does TrailDB compare to existing solutions? Well, I mean, it is designed to be very complementary in the sense that, like, of course, you could be using relational DBs like Postgres. And actually, AdRoll is using Postgres for many different use cases. But typically what happens with relational databases is that, of course, I mean, you have a primary key. Like you could have actually, we do have a table called users, and it has a primary key, which is the user ID. And that table happens to include a column that's called last login date, so the last time the user logged into the site. And now every time you log into the site, we get the event and we update that column that says the last login date. But now the problem with the relational DB is, of course, that you don't know the previous login date. You only know the latest one. I mean, you make these destructive updates and you lose the history. So when you have the primary key and you have these events, that's totally fine, but you don't have the history anymore. And now, of course, you are like totally, I mean, it's totally possible to have a table that records the history as well, but I mean, that's kind of extra work, and like it's really not what the relational model is kind of natively about. Then another very interesting type of database is time series database. So a typical example is for instance, like monitoring, like infrastructure monitoring. So we use this service called Datadog, where you can send metrics about the CPU utilizations or whatever disk I/O happens. And what it does is that, like, again, I mean, there's a primary key, which in the case of Datadog is an instance ID or server ID. And now you can like send them like how much like a CPU are you using. And what Datadog does is that they aggregate this information by minute or by hour or by day or whatever. And then like over time you get this like a nice time series, the history that like what happened with the CPU utilization. But now the thing is that like, well, first, I mean, this is only possible if you have continuous metrics that you can aggregate over time. Imagine that like you had JSON objects and like you wanted to kind of store all the fields. I mean, you couldn't just aggregate them. And then secondly is that like, well, I mean, you kind of lose the original events. You just get this aggregate version, which is totally fine for some use cases, but not for all. And then lastly, of course, the very basic case is that like you have those events and you keep adding events in a log file, let's say a simple CSV file. And that's also something that we do at AdRoll. And you keep recording these, let's say you like rotate these files daily, so you get these daily files and you can keep them forever, whatever. And then they totally contain all the history and all the events. But now the challenge is that, of course, using data like this is somewhat inefficient. The de facto solution for handling data like this for the past 10 years has been to use MapReduce, and also we use MapReduce at AdRoll. But the challenge is that first, I mean, it is, of course, pretty inefficient. It takes a lot of time and a lot of computational resources to run MapReduce jobs over large amounts of data. And secondly, as you may know, if you have ever used Hadoop or something like that, it is not very natural to express many types of data science problems in the MapReduce paradigm, and that's why you have all the libraries that are written on top of it. So the point is anyway that it is actually very useful to have a database that not only has the history and events, but it also makes querying this data very efficient. And that's really the kind of the use case we wanted to solve with TrailDB. And if there's a single thing that I want you to remember from this presentation, is really the next slide. And that's really the secret sauce of TrailDB. So it happens that when you focus on a very particular data model, so you assume that you have these users and you have these events over time, you can actually do all kinds of things that you wouldn't be able to do otherwise in a general purpose database. And like one of the things that it actually makes a huge difference is compression. So you can compress the data way more efficiently than you were able to do otherwise. And of course, this is the same thing what many columnar databases are doing these days. So if you have been using Parquet or something like that, it's the same idea that like if you can fix the data model, if you can fix the columns, you can compress every column in a very efficient manner. But TrailDB can do even more. And the reason for that is that like things tend to be very predictable over time. So actually going back to this visualization here. So if you look at these things here, you can see that these things are very predictable. So there are some sites that actually are way more active, some sites that have more red dots, some sites that have more yellow dots, some things that are very sparse. So obviously it is something that you can predict. And now, like as you may know, there is a very tight connection between compression and predictability. So let's say that like if you were not able to predict something, if something was totally random and pure entropy, I mean, you couldn't compress anything. That's pretty much the kind of the point of information theory. On the other hand, like if something is totally predictable, I mean, you can actually compress it in a very small space. So what TrailDB does is that it actually leverages the fact that users and the user behavior is very predictable. So imagine, for instance, that you had one user who lives in Ukraine, So I mean, most likely this user visits Ukrainian or maybe Russian-speaking websites instead of any random site in the world. Or let's say that like there's a person who lives in the United States. I mean, this person is likely to be active in a certain hours of day and so forth. So you can definitely kind of compress things kind of horizontally. I mean, like people are predictable. Also, what's really interesting is that there are certain things globally, certain things overall that are actually very predictable, like across users. So, and like one example is that, let's say certain websites are way more popular than others. So for instance, likelihood that any single user would be visiting youtube.com and at any point of time is way higher than that the user would be visiting one of the sites in the long tail of the domain distribution. So in that sense, again, I mean, like we can leverage the fact that like YouTube just happens to be a popular thing globally to compress the data and like use fewer bits to encode the data. So the point being that like TrailDB really focuses on compressing data that is stored and that follows this data model. Okay, so now you may think that, okay, well, I mean, may be interesting in kind of a theoretical point of view, but I mean, like you can use zzip and like you can use, I mean, there are many different compression methods. Well, that kind of, like for the purposes of TrailDB, I mean, kind of isn't very useful. And the reason for that is that like with zzip, it definitely helps when you store the data, it makes it smaller. But then when you start to analyze the data, you have to decompress everything and suddenly you have big data to be analyzed. So what you want is that you want to store small data, but you also want to analyze small data because analyzing small data is fast. And this is actually a chart that I stole from an old presentation of mine. You can find the whole presentation there. But what it shows you is that this is actually on the y-axis is the number of integer operations that CPU performs per microsecond. And on the x-axis, we have kind of the amount of data we are handling. And now what happens is that like if your data is so small, let's say less than 16 megabytes, so that it fits in the L3 cache of your CPU, you can basically saturate the CPU and the CPU can deliver, like in this case, almost 4,000 integer operations per microsecond, which means that like you can do amazing amount of number crunching in a time unit. And now, of course, like if your data happens to be a bit bigger and like more than 60 megabytes, well, I mean, then you have to store it in RAM and like things are a bit slower because you have to move stuff between RAM and the CPU. But I mean, still kind of okay-ish. I mean, like we can still do like 2,500 operations per second. And then, oh horrors, if the data is so big that it doesn't fit in the RAM, I mean, then it's basically game over and like things become horribly slow. And now the point here is that like if you can decide the encoding and if you can choose the encoding of your data in such a way that you can actually operate in this space, things become fast. And now again, I mean like, okay, so that's, again, I mean you might think that, okay, being fast is kind of nice, but I mean like what's the point? Well, I mean, again, I mean going back to the original justification that like AdRoll has kind of no idea what we are doing and we have a small team, so we need to be able to iterate fast. We need to be able to try out different things quickly. So actually, like the speed is not only about like, well, I mean, letting our computers to idle, but it's rather the question of making our data scientists productive. I mean, being able to test and try out different hypotheses faster. And that's really the point. Another really important point when it comes to productivity is simplicity. And that's also another like very important thing about TrailDB is that many of the big data platforms or like even like a big data ecosystems these days are actually hugely complex. You have many different tools and like you have many different overlapping solutions to the same problem. And actually, I really do believe in simplicity. And like TrailDB is actually like as simple as it gets. I mean, it gives you one file. The file is also immutable, so you can just manipulate the file in many concurrent processes and nothing ever gets corrupted. You can put the file on a USB stick and give it to your friend and whatever. So it's really as simple as it gets. And of course, I mean, you can copy the file to Amazon S3 and you can store terabytes or petabytes of these files if you want, like what AdRoll does. So it's very simple. Also, because like you get these files, I mean, like TrailDB resembles like something like SQLite or LevelDB or any other embedded database rather than like Postgres already, so it's a library. And I'm not sure if I mentioned, but I mean, it's also implemented in C, so again, for performance reasons. And of course, since it's immutable, you can only create TrailDBs, you can read them. But I mean, like, the idea is not to change the data. And that's totally fine by us, since if you think again, those visualizations, I mean, whatever happened in the past, I mean, doesn't change. I mean, we don't need to change history. I mean, that's fine. So this actually yields also many architectural benefits, especially when it comes to cloud computing. So there's actually a separate presentation that like we have given about the whole like AWS architecture around TrailDB and how you can actually analyze huge amount of data in a very cost-efficient manner when you do things this way. But that's a separate topic. So talking about C, so of course we don't assume that like sane people use C for like much anything. Which is why TrailDB provides many different bindings to different languages. So AdRoll is like really a crazy company when it comes to engineering. So you don't find any other company like AdRoll, I believe, in San Francisco. I mean, at least at this scale. So we use pretty much every single language out there, like in production tasks. So we use Julia, we use D, we use Lua, we use Python, we use Erlang, we use Haskell, we use R, and like we use all these different languages. And partly it is because we can. I mean, you can always use the best tool for the job. And then partly, of course, it's fun for engineers. So we are hiring, and if you want to use some crazy language, I mean, come to AdRoll. But the benefit of like TrailDB being written in C is that it's very easy to provide language bindings. And TrailDB, actually today, you can go to GitHub, and you will find all these language bindings. And I know that people are working on bindings for JavaScript with Node.js and bindings for PHP, if there are any data scientists who want to use PHP, maybe at Facebook. So yeah, so it's very polyglot. And of course, like it has a very clean API following the idea of simplicity. So like I mentioned, you can create TrailDBs based on raw events. This is actually a surprisingly useful operation that you can merge existing TrailDBs. And then when it comes to accessing the data, you can like obviously like find like events related to a certain user given the UUID or a trail ID. You can iterate over a trail, and like one really important thing about this is that all these operations are lazy. So for instance, we have one user who has generated over hundreds of thousands of events over time. And now you can imagine that it's actually not very efficient if you are interested in only a certain thing. I mean, to kind of take all this data at once. So what you can do is that like TrailDB gives you this like a lazy cursor over the data, so you only get what you really need. Another big topic is that not only TrailDB is implemented efficiently internally, but it also encourages you to build applications in very efficient ways. Namely, one thing that makes computers very happy are integers. So computers are very, very good with integers. So TrailDB is very much built around this concept of like you handling integers in different ways. Of course, people are not so good with integers, so it provides APIs to kind of convert back and forth between strings and integers. But the bottom line is that, like, especially if you want to compute summary statistics or you want to find certain patterns, I mean, it's much better to kind of operate with integers rather than strings, just for efficiency reasons. And then lastly, oftentimes what you want to do is actually to focus on a certain subset of events. Let's say you are only interested in analyzing data from mobile phones, or you are only interested in analyzing data from whatever certain country. So I mean, you can actually express it, like have a Boolean expression over these fields and say that, okay, give me only events that satisfy these conditions. So as the kind of the last part of my presentation, I just want to make it more concrete to show you how it actually looks like. So this example here is written in Python, but as I mentioned, I mean, we have many different language bindings. Like by all means, if you don't like Python, I mean, there's probably a language that you will like, and if not, I mean, let us know. But I mean, just to give you an idea, like what it looks like in practice. So in this case, we want to create a new TrailDB. And what you do is that, like, first you define a new TrailDB constructor. You announce that, okay, I'm going to build a new TrailDB. You basically define a schema that says that, okay, these are the fields that my TrailDB is going to contain. In this case, username and action. And then you give it some name, tiny in this case. And in this example, we are going to generate like synthetic data on the fly. So we assume that we are going to have 3 users, and like we come up with some usernames. And we assume that like every user performs 3 actions: open, save, and close. And then we add these events in TrailDB. So there's a simple add method that takes the user ID, timestamp, and then the actual event. So some username and action. And of course, now the idea is that in real case, in a real application, you would have your own data source. Maybe it's an existing database, or maybe it's a CSV file, or maybe it's a massive fire hose of real-time data. But I mean, that's basically the interface that you get. And now the interesting part is that like since TrailDB is an immutable database, at some point you want to say that, okay, I'm done with this chunk. Maybe you do it every hour, maybe you do it every day. Then you call finalize, and that's actually the part when the data actually gets compressed. But I mean, that's it. Then you get this one beautiful file, and you can do whatever you want with the file. One thing that like you may want to do with the file is actually open the file later and like start doing some like data analysis. Quite simply, I mean, what you do is that you instantiate a new TrailDB, you give it the path, and then you can, in this case, start iterating over everything that's included. And in this simple example, you get the same stuff out, what we generated in the previous slide. And so you get the user IDs, and you get these events, and note that actually the timestamps are ordered. So it's really, if you remember those like X and Y axes, so it's all the users and like all the events ordered by time. And that's what you get. And well, I mean, like I mentioned, I mean, this example is in Python, but it looks very similar in many other languages. We actually have a pretty active Go binding, so if you like Go, so I mean, it's pretty efficient and nice. Okay, so as the last thing, I know that I'm kind of running out of time, is that so the visualizations that I showed you in the first slides, that's actually like my favorite type of visualization. Really nice way to really visualize large amounts of data. It's made possible by this amazing package called Data Shader. I highly encourage you to kind of take a look. But this is an example. You can actually find these slides online after this talk, so you can try this at home. So if you want to like create visualizations like that by yourself, what all you have to do is to basically install TrailDB. You can go to traildb.io. There's a getting started guide. You can follow that. You install the Python bindings, very easy. You follow the installation instructions for the data shader package. And now, of course, the question is that, okay, so I mean, okay, what's the data we want to visualize? I mean, and if you are open to joining AdRoll, I mean, you are more than welcome to visualize AdRoll data. But in other cases, there's some like interesting public data that's available. One really nice data set that we have made available at the TrailDB site is actually a TrailDB of all Wikipedia edits since the beginning of time, since the beginning of Wikipedia. And it's actually a very fascinating data set. So it contains 663 million events, basically someone editing Wikipedia. And it has the username of the person who made the edit, it has the page title, it has the IP address, it has the second level timestamp when the edit took place. And really the interesting fact is that taking everything that has ever happened in Wikipedia, the result is just 5.8 gigabytes, so something that you can easily do on your laptop. So if you do the math, it means that we are basically using about 9 bytes like for every event to store the timestamp, the username, the page title, and the IP address. And now, of course, I mean, given that we are using even like a 64-bit timestamps that are 8 bytes, I mean, it's pretty remarkable how well you can compress data like this. Well, anyway, the bottom line is that like you get this nice data set of all Wikipedia edits. Now, I mean, like, this is kind of like about, I guess, like 20 lines of code or something. That basically all it does is that it goes through the TrailDB, takes all the timestamps and takes the user ID, or the kind of the row ID, and then it actually takes or sees if this is an anonymous user or a logged in or registered user, and it actually creates a pandas data frame, because this data shader package happens to like pandas data frames. So it creates this data frame, and here it just creates a new canvas, and it adds all these points from this data frame to the canvas, and then it adds some colors, and then it writes the result to a PNG file. Again, I mean, the slides will be available, so you can easily try this at home. Or if you are working in a company, I mean, maybe you have some data from your website or something, you can easily visualize in this way. And this is actually a really nice way of like finding great insights about data. So just to give you some last example, I focused on a particular subset of Wikipedia, namely in this case, one page about Prince, the artist. And like here in this visualization, again, x-axis is time, y-axis is users. What do you see? And this is actually, I guess, I mean, I don't know when Wikipedia started, like 2000 something, 2001 maybe. So the 2001 would be here. And then you can actually see that there's a lot of activity happening on this page, like people editing prints between maybe, I don't know, like 2005 to 2010 or so. And you can see, if you really look closely, is that there are these red dots that are people making anonymous edits. You can actually see that they are dots. So typically, if you're anonymous, you just do something and then you never come back. And then you have these blue lines that correspond to people who actually registered to Wikipedia and they make multiple edits. So you can see that actually there are these like lines that correspond to people who have made multiple edits over time. And maybe there's someone in the audience who knows more about Prince, but I mean, for some reason, maybe he stopped like making music at some point, like in 2010. But I mean, it seems that there isn't that much activity. But unfortunately, then in like April 2016, he died. So expectedly, I mean, there's like a huge amount of edits that were made in April when everybody wanted to kind of go and edit the page about this unfortunate event. One thing that I wanted to note here is that, of course, a visualization like this, well, it answers some questions, but it also raises other questions. So, I mean, one question is that, does this really mean that like everybody who has ever edited the page actually came back to make edits about the death? And one way to kind of make the visualization more clear with that regards is to, again, to order the rows. And what you get when you order the rows is that you can actually see, and this time it's actually ordered by the first edit date, so the first time they made an edit on this page. You can see that actually in the beginning of Wikipedia there weren't that much activity, it took a while. But then like between, again, I mean 2005, 2010, there's like a bunch of activity. You can see the red dots, like anonymous people coming and edit the page. And then you can see again these like blue lines, meaning that there are some like dedicated fans who get editing the page. And then like for some reason the anonymous edits ended in 2010, and then like the red dots disappear, and you can just see that this line of like people, registered people editing. And then the interesting fact is that then finally when he died, actually most people who came to make edits are totally new people. They have never made any edits before at that page. I mean, like there are some cases when they were like people with existing edits, but like most of them seem to be new. So it's just like a very fun way to do very like exploratory data analysis, like very easily using large amounts of data. So again, I mean, just to remind you, I mean, this is all Wikipedia, like everything, every single edit that anyone has ever done, and it's 5.8 gigabytes. It fits on your laptop, and you can do easily it in Python. So that's kind of a type of like productivity and simplicity that we like. So as the kind of to conclude the presentation, I mean, like to motivate you to try TrailDB at home, like some kind of calls to action, as we call them here. So well, I mean, first, I mean, like as I mentioned, it's a very good match for like something like AWS or Google Compute Engine, because you can easily store these immutable files in something like S3. It's very efficient. It's written in C, it's high performance, small code base, minimal dependencies. Your DevOps people will like you. It's actually well tested. And also, I mean, like one thing that's really important is that this is not the kind of a hobby project that like we hope that you will fix. But it's actually something that we have been using to power actually like remarkable business producing millions of dollars of money over the past 1.5 years. So it's actually probably works. I mean, let us know if it doesn't. Another hugely important topic when it comes to data, and this is something that I wish that more open source projects would follow, is that imagine that like you start using TrailDB and like you become really excited and you start storing your company data in TrailDB, and then maybe 6 months from now, I mean, we make a new release and we say that, look, I mean, we came up with the new compression method, and like all the data you have in TrailDB suddenly became unreadable. I mean, you can't access it anymore unless you migrate the data to a new version or something. And of course, that never happens. I mean, like we have terabytes and terabytes of data stored in TrailDB, so we will never change them. I mean, they are immutable and they are stored. So not a single time in the history of the project we have broken the backwards compatibility. So, I mean, we take that very seriously. So I wish that more open source project would take this operational aspect really, really seriously. We are friendly people. You can like find us on Twitter. And we have actually a number of very exciting tools that are built on top of TrailDB that we hope to open source soon, that, for instance, allow you to detect and find different patterns, like in a very efficient way. So we might have Oleg here somewhere in the audience. So he's the author right there. He's the author of like one of the key tools that we are using. You can go and talk with him about that. And I guess that's everything I have. So I mean, like really, as I mentioned, go to TrailDB.io. You will find interesting information there. If you want to chat with us afterwards, after this meetup, we have a chat room in Jitter, and my email is my first name @adroll.com. Thank you.